So why is this type of record interesting? Basically, it condenses all the hard work during 6-7 years. We put everything to the test.
To develop and commercialize a new graphene aluminum-ion battery that, according to early tests, may be able to fully charge in 5 minutes or less.
Christian von Koenigsegg, the founder and CEO of Koenigsegg, has just made a historical announcement at a private event. He revealed the new aluminum-ion super battery that will completely change the automobile industry. This innovation promises to charge in just 15 minutes while delivering exceptional performance and sustainability.
Lithium-ion battery pack is attributable to high-performance cooling systems, which can be eliminated in most aluminum-ion battery use cases.
Known for pushing boundaries, Koenigsegg presented this as a potential game-changer for electric vehicles. Could this be the next big step in making electric cars faster, greener, and more convenient? Join us as we reveal in detail the new super battery of Koenigsegg. Koenigsegg CEO announces new super battery. At a private event attended by top automotive experts, media representatives, and industry insiders, Christian von Koenigsegg, the CEO of Koenigsegg, made a groundbreaking announcement. He revealed a revolutionary aluminum-ion super battery that has the potential to change the future of electric vehicles. This new battery promises ultra-fast charging, taking only 15 minutes to reach full capacity, while delivering superior performance, safety, and sustainability compared to traditional lithium-ion batteries. Koenigsegg has built a reputation for pushing the boundaries of innovation, and this battery represents yet another leap forward. The company's hypercar, the Gemera, is currently using this cutting-edge technology, and it proves its capabilities in a real-world application. The Gemera is not just any car, it is the world's first 4-seater hypercar, combining luxury, breathtaking speed, and eco-friendly technology. With a hybrid system that integrates the aluminum-ion battery, the Gemera is designed to deliver unparalleled performance without compromising on environmental responsibility. But is this super battery really the game-changer for the electric vehicles industry? And how does it work? Keep watching to find out. The aluminum-ion battery works differently from the more common lithium-ion batteries found in many devices today. The main difference is in the materials used and how the battery stores and releases energy. Instead of lithium, this battery uses aluminum, a metal that is lighter, more abundant, and easier to recycle. In an aluminum-ion battery, the process of storing and releasing energy involves ions moving between two electrodes. The battery has two parts, the anode, which is the positive side, and the cathode, which is the negative side. In the case of the aluminum-ion battery, the anode is made from aluminum, and the cathode is typically made from a material like graphite. When the battery is charging, aluminum ions move from the anode to the cathode. When discharging, or when the battery is being used to power something like a car, the ions move back from the cathode to the anode, creating an electric current that powers the device. What makes the aluminum-ion battery stand out is that it allows electricity to flow more easily than in traditional lithium-ion batteries. This design enables it to charge much faster, sometimes in just 15 minutes, compared to the hours it can take for lithium-ion batteries to charge. This is because aluminum ions are smaller and more mobile, allowing them to move through the battery's materials quickly, making charging and discharging more efficient. In cars like the Koenigsegg Gemera, the aluminum-ion battery is designed to work seamlessly with the Gemera's hybrid system, providing power to its electric motors and supporting the internal combustion engine when needed. In the Gemera, the aluminum-ion battery stores energy that is used to drive the car's electric motors. This means that the car can run on electricity alone at low speeds, or in situations where high power is not required. For example, during city driving, the Gemera can operate quietly and with zero emissions, using only the electric motors powered by the aluminum-ion battery. The battery is integrated with the car's hybrid system. When more power is needed, such as during high-speed driving or acceleration, the battery works alongside the car's internal combustion engine to provide extra power. This hybrid setup allows the Gemera to deliver the extreme performance Koenigsegg is known for, without sacrificing fuel efficiency or emissions. The aluminum-ion battery in the Gamera also supports regenerative braking. When the car slows down or brakes, the electric motors act as generators, converting kinetic energy into electricity, which is then stored back in the battery. This process helps recharge the battery and ensures that energy is not wasted, making the car even more efficient. The battery is not only designed to power the car, but also to handle the car's high-performance demands. The Gamera's electric motors require a large amount of energy to operate at their best, and the aluminum-ion battery is able to deliver this power quickly. Unlike traditional batteries that can slow down under heavy load, the aluminum-ion battery in the Gamera
Koenigsegg has managed to create an electric motor that's not only efficient, but also incredibly powerful.
is designed to deliver consistent, reliable power, even when the car is being driven at its maximum speed. One of the main features of the aluminum-ion battery is its ability to charge very quickly. In the Gamera, this is especially useful, as the battery can charge to full capacity in just 15 minutes. This fast charging ability is possible because of the unique design of the battery, which allows electricity to flow quickly and efficiently. When the car is plugged in, the battery is able to charge much faster than traditional lithium-ion batteries, which typically take hours to reach full capacity. How did the Koenigsegg company develop the aluminium-ion battery, and why is it a game changer? Stay tuned, because what comes next will shock you. The game changer called aluminium-ion battery, and how it was developed. Koenigsegg's development of the aluminum-ion battery is a major milestone in the world of electric vehicles. Unlike most current electric vehicles that rely on lithium-ion batteries, which have certain limitations, Koenigsegg's aluminum-ion battery promises to address these issues while offering better performance, quicker charging, and enhanced safety. But creating this innovative battery wasn't easy, and it took years of research, testing, and refinement to bring it to life. The company's engineers and designers worked tirelessly to create a battery that would meet the high-performance demands of their hypercars, like the Gamera. They understood that, for an EV to truly compete with traditional gasoline-powered cars, it needed to offer a combination of speed, range, and charging convenience. The challenge was to develop a battery that could provide these features while being more environmentally friendly than current lithium-based solutions. The team started by looking for alternative materials to replace the common lithium found in traditional batteries. Lithium-ion batteries have been used for years in electric vehicles, but they have some drawbacks. They are relatively heavy, take a long time to charge, and can sometimes overheat or even catch fire. The engineers at Koenigsegg turned to aluminum as a potential solution because it is lighter, more abundant, and easier to recycle than lithium. This choice not only made the battery more environmentally friendly, but also allowed for a lighter and more efficient design, which is critical in high-performance cars like the Gamera. Over the years, Koenigsegg's team experimented with different materials and tested various designs to improve the battery's performance. They focused on making the battery lightweight yet powerful, with the ability to store and release energy efficiently. One of the breakthroughs was improving the flow of electricity within the battery. This made the battery not only charge faster, but also discharge quickly when needed, supporting the car's performance needs during high-speed driving. This was a crucial feature, as most traditional electric vehicles take several hours to charge, limiting their practicality. Koenigsegg's aluminum-ion battery charges in just 15 minutes, a game-changer for anyone who wants the convenience of fast refueling. The safety of the aluminum-ion battery was another critical consideration. Lithium-ion batteries, while widely used, have a higher risk of overheating or catching fire under certain conditions. Aluminum, however, is more stable and less prone to these issues. The aluminum-ion battery wasn't just made to power the Gamera, it was made to enhance its performance, handling, and overall driving experience.
The auto industry is undergoing a major shift towards electric vehicles.
Major indeed. The Biden administration is projecting that 2/3 of all vehicles in these United States will be electric by 2032.
This development is a game changer for the electric vehicle industry because it addresses several major challenges. The aluminum-ion battery offers faster charging times, making it far more practical than other options available today. It also reduces the environmental impact by using more sustainable materials and is less likely to pose safety risks, unlike lithium-ion batteries. Most importantly, it allows Koenigsegg to continue creating high-performance, high-speed cars that don't rely on traditional fuels, making it an important step toward the future of clean energy in the automotive world. What are the benefits of aluminium-ion batteries, and what does this mean for the future of the electric vehicles industry? Keep watching to find out. Benefits and setbacks of the aluminium-ion batteries. The aluminum-ion battery used in cars like the Koenigsegg Gamera has a number of advantages that could change the way electric vehicles operate. One of the main benefits is its fast charging capability. Unlike traditional lithium-ion batteries, which can take hours to recharge, the aluminum-ion battery can be fully charged in just 15 minutes. This is a huge improvement and could make electric cars more practical for everyday use, as drivers would not have to wait for long charging times. The fast charging feature could bring electric cars closer to the convenience of refueling a gasoline-powered car, making electric vehicles more appealing to the mass market. Another advantage of the aluminum-ion battery is its lighter weight compared to lithium-ion batteries. This lighter design helps to reduce the overall weight of the vehicle, which can improve performance and efficiency. In cars like the Gamera, which combine high-performance capabilities with sustainable technology, this lighter battery helps maintain the car's power-to-weight ratio, ensuring it performs at its best without compromising on range or agility. The reduced weight also makes the car more efficient, as it requires less energy to move, allowing for longer driving ranges on a single charge. Safety is another major advantage of the aluminum-ion battery. Lithium-ion batteries are known for being prone to overheating and, in some rare cases, catching fire. The aluminum-ion battery, however, is much more stable. It is less likely to overheat or fail in extreme conditions, making it a safer option for high-performance vehicles like the Gamera. This added safety could give consumers greater confidence in using electric vehicles for a wider range of activities, from city driving to long road trips. The environmental impact of the aluminum-ion battery is also a major advantage. Aluminum is more abundant and easier to recycle than lithium, which means the production and disposal of these batteries can have a smaller environmental footprint. This is particularly important as the world pushes toward more sustainable solutions to combat climate change. The ability to recycle aluminum-ion batteries more easily could help make electric vehicles even more eco-friendly, especially when compared to the challenges surrounding the recycling of lithium-ion batteries. But there are also some setbacks to the aluminum-ion battery. One of the main challenges is that while the battery is lighter and can charge faster, it is not yet as widely available as lithium-ion batteries. The technology is still in the development phase, and scaling it up for mass production will take time. This means that aluminum-ion batteries are currently limited to a small number of high-end, performance-oriented vehicles like the Koenigsegg Gamera, and it may be a while before they become common in everyday consumer cars. Although the battery's efficiency and lightweight design help mitigate this to some extent, there is still room for improvement in terms of how much energy it can store, especially for longer trips or larger vehicles. Also, the development of the aluminum-ion battery requires ongoing research and testing. While the battery is already being used in the Gamera, there are still challenges to overcome in terms of manufacturing, cost, and performance consistency. As more car manufacturers and researchers work on refining this technology, we could see improvements in its capacity and cost-effectiveness. However, this is just the most recent achievement of the company, which has been making strides in this field even before today's advanced technology. In 2016, EHang introduced the EHang 184 at the Consumer Electronics Show, which was the world's first autonomous aerial vehicle capable of carrying passengers. In 2017, the company made plans with Dubai's Road and Transportation Agency to launch a flying taxi service, though this project did not succeed. EHang has also collaborated with Nevada's Institute for Autonomous Systems to develop an air taxi that could transport one passenger for up to 23 minutes with the EHang 184 model. In November 2018, the company signed an agreement with the city of Lyon, France, to establish a research center there. Around the same time, it entered into a partnership with Austrian aerospace company FACC to further develop, certify, and produce their vehicles in Europe. EHang was listed on the Nasdaq in December 2019 under the symbol EH. By March 2020, the company formed a strategic partnership with Liria, a city in Spain, to develop urban air mobility solutions, including tourism and logistics. Liria is the second Spanish city with which EHang has formed an agreement. In October 2023, the EH216S model received approval for commercial flights from the Civil Aviation Administration of China.
What was once considered science fiction has now become a reality, and flying cars are ready for takeoff. China's EHang is the world's first company to create a certified airworthy passenger-carrying flying taxi.
EHang has developed several innovative aircraft, with the first being the Ghost. This is a quadcopter built in the standard quadrature design, but with a unique feature. Its rotors are mounted below the arms rather than on top.
And I have to say I'm pleasantly surprised by the weight. It feels substantial in my hands. But the airframe and the undercarriage are made of plastic,
as seen in most other multi-rotors. The Ghost, officially named the Ghost Intelligent Aerial Robot, is primarily used for aerial photography and is controlled via smartphone.
The drone, instead of using the transmitter, you use the phone based on this application. So tilting left to right, up, down, forward, backwards, it's all commanded with the phone to the drone.
Its specifications include a wingspan of 0.35 meters, 1 foot 2 inches, a gross weight of 0.68 kilograms, 1 pound, and 4 propellers. In terms of performance, it reaches a maximum speed of 60 kilometers per hour, has an endurance of 25 minutes, a service ceiling of 914 meters, and a climb rate of 2.5 meters per second. Another aircraft EHang developed is a hexacopter that has yet to be named. This UAV, made from carbon fiber composite material, was first shown to the public in August 2014 at TechCrunch Beijing. Unlike most multi-rotors with straight arms, this hexacopter features curved arms and has a pair of skids as landing gear. Controlled by a laptop, the hexacopter can carry a capacity of 10 kilograms with 6 propellers. Its performance includes a range of 5 kilometers and an endurance of between 30 to 40 minutes. Perhaps EHang's most impressive creation is the EHang 184, an autonomous passenger drone.
To this drone you see behind me, the EHang 184.
Capable of reaching speeds over 100 kilometers per hour, it began carrying passengers in 2015, with over 40 trips completed by February 2018. In the 3 years leading up to that, more than 1,000 test flights were conducted, including challenging flights in stormy conditions, low visibility, and nighttime operations. The EHang 184 has 8 propellers mounted on 4 arms and can carry 1 passenger. By July 2018, 30 to 40 single-pilot models had been built. The drone's specifications include a length of 3.86 meters, a wingspan of 5.5 meters, and a height of 1.44 meters. In terms of performance, it has a cruise speed of 130 kilometers per hour, a range of 16 kilometers, and a service ceiling of 500 meters. EHang 216 is a 2-seater aircraft equipped with 16 propellers arranged in a coaxial double-blade design. By July 2018, it had completed over 1,000 manned flights, with its longest distance flown being 8.8 kilometers. It can stay airborne for about 25 minutes, covering a range of 30 to 40 kilometers, 16 to 22 nautical miles. The aircraft is designed for autonomous flights, which are monitored remotely from a command and control center operated either by EHang or its customers. EHang has partnered with Austrian aerostructures supplier FACC AG to certify and produce the aircraft in Europe, benefiting from the simpler certification requirements for aircraft with a takeoff weight under 600 kilograms. In October 2018, the Civil Aviation Administration of China, CAAC, approved initial passenger operations at select locations to help establish regulations for urban air taxis. Since then, EHang has started taking pre-orders, especially for island-hopping trips and aerial sightseeing at a coastal resort in China. Additionally, a shuttle service across a 1-kilometer stretch of the river in Guangzhou has been introduced, reducing a 30-minute car drive caused by traffic congestion. EHang has also partnered with United Therapeutics, a US-based biotechnology company focused on manufacturing organs for transplants, to test the rapid automated delivery of organs from laboratories to hospitals by the end of 2019. In March 2020, the Norwegian Civil Aviation Authority granted EHang a permit for manned test and certification flights, marking the first such approval in Europe. On May 27, 2020, EHang received the world's first commercial pilot operation approval from the SAAC to use its EHang 216 AAVs for air logistics. Additionally, the EHang 216 was awarded a special flight operations certificate by Transport Canada Civil Aviation for test flights in Quebec. The aircraft's general specifications include no crew, as it is self-piloted, a capacity of 2 passengers with a combined weight of 260 kilograms,
can transport up to 2 passengers with a total payload of 220 kilograms over a distance of roughly 35 kilometers with a top speed of 130 kilometers per hour.
A length of 5.61 meters, and a height of 1.76 meters. In terms of performance, its maximum speed is 160 kilometers per hour, with a cruising speed of 130 kilometers per hour and a range of 16 kilometers. The EHang 216S version has an expanded range of 32 kilometers, powered by a 17 kilowatt-hour battery, and cruises at a speed of 60 miles per hour. Another version, the EHang 216F, is specifically designed for firefighting, particularly in high-rise buildings. This model can fly up to 600 meters high and carry 150 liters of fire extinguishing materials. It also comes equipped with a camera that helps to locate fires independently. Evolution of flying cars. Even before the Wright brothers took flight in 1903, the dream of flying was alive. In 1856, a French aviator named Jean-Marie Lebris created a glider that was inspired by the albatross. In one of his attempts, this early flying machine managed to carry him nearly 300 feet off the ground. In 1901, Gustav Whitehead, a German immigrant in the US, reportedly flew a powered aircraft that could move along roads before taking off for the experiment. However, historians generally agree that Whitehead's aircraft did not achieve sustained self-powered flight. When did the real breakthrough happen? And do we have a perfect flying car today? The excitement is building, and it's about to get even more interesting. Companies like Joby Aviation and Archer Aviation are already working on electric vertical takeoff and landing vehicles (eVTOLs). Even major players like Uber and the US Air Force are getting involved, with plans to use flying cars for transporting people and cargo. While the concept of flying cars seems like something out of a Hollywood movie or a Silicon Valley innovation, the idea has actually been around for more than a century. The first patent for a vehicle that could both drive and fly was filed back in 1910. Henry Ford also had high hopes for a single-seat aircraft he called the Ford Flivver, though it never became a reality. In 1917, aircraft designer Glenn Curtiss developed the autoplane, which had a pusher propeller and detachable flight surfaces, including a triplane wing and twin tails. Although it could hop, it never truly flew. In 1935, Konstantinos Vlachos built a prototype of amphibian vehicle with a circular wing, but it caught fire during a demonstration in Washington, D.C. after the engine exploded. Vlachos was severely injured and spent months in the hospital, with the incident being notably captured on a newsreel. The first real success came in 1937, with the Waterman Aerobile taking flight. However, despite its innovative tailless design and 2-seater capacity, it didn't gain much popularity, and only 5 units were ever made. In 1942, the British Army developed the Hafner Rotobuggy, an experimental rotable autogyro designed to airdrop off-road vehicles. The Rotobuggy, in its advanced form, managed to achieve a flight speed of 70 miles per hour. However, with the introduction of gliders that could transport vehicles, such as the Waco Hadrian and Airspeed Horsa, the project was eventually cancelled. Then, in 1946, the Fulton FA-2 Amphibian, a rotable aircraft, was introduced. Though not very practical, it featured removable tail sections and wings, adding to the growing list of flying car concepts. During the same period, the Convair car of the 1940s emerged, which was essentially a sedan attached to an airplane. In 1959, the Canadian and British military created the Avrocar, the first flying car specifically designed for military use. It had a saucer-like appearance rather than a traditional car design. Fast forward to 2009, the U.S. Defense Advanced Research Projects Agency, DARPA, launched the Transformer program with a budget of $65 million, aimed at developing a 4-person roadable aircraft by 2015. This vehicle was intended to have vertical takeoff and landing capability and a range of 280 miles. Contracts were awarded to AAI Corporation and Lockheed Martin, but the program was canceled in 2013. Around the same time, the Parajet Skycar was developed, using a paramotor for propulsion and a parafoil for lift. The vehicle's body resembled a modified dune buggy. It could reach a top flight speed of 80 miles per hour, with a maximum range of 180 miles in the air. On the ground, it had a top speed of 112 miles per hour and could travel up to 249 miles. In January 2009, Parajet flew and drove its prototype from London to Timbuktu. The Maverick Flying Dune Buggy, designed by the Indigenous Peoples Technology and Education Center of Florida, was created as an off-road vehicle. It could deploy an advanced parachute and travel by air when roads became inaccessible. Weighing around 1,100 pounds, the Maverick was powered by a 128-horsepower engine, which also drove a 5-bladed pusher propeller. Originally conceived to assist remote communities in the Amazon rainforest, it has also been marketed for tasks such as visual pipeline inspection in hard-to-reach areas. The plane-driven PD-1 roadable Glasstar is a modified version of the Glasstar Sportsman GS2, designed to be a practical roadable aircraft. What makes this design unique is that it largely uses the original aircraft with a modified landing gear pod that houses the engine for road use. Its wings fold along the sides, and the landing gear and engine pod slide backward when in driving mode to maintain balance and improve stability for road travel. The Super Sky Cycle, another roadable aircraft, was an American home-built gyroplane created by the Butterfly Aircraft Company. Interestingly, it was officially registered as a motorcycle. Then, in 2014, Aeromobile introduced version 3.0 of their flying car at a festival in Vienna, Austria. This concept was developed to transform from a regular car into an aircraft. Aeromobile's version 2.5 took 2 decades to develop and made its first flight in 2013. The company's CEO revealed plans to bring flying cars to the market by 2017. By 2016, Aeromobile was test flying a prototype that had gained Slovak ultralight certification, though the final release date or cost details remain unknown. In 2018, they showcased a new design that resembled a sporty flying car with vertical takeoff and landing capabilities. The Aeromobile 2.5 comes with folding wings and a Rotax 912 engine. It can reach speeds of 200 kilometers per hour with a range of 690 kilometers, having its first successful flight in 2013. On October 29, 2014, the Aeromobile 3.0 model was publicly unveiled at an event in Vienna by the Slovak startup Aeromobile. The Aerocar, created by aeronautical engineer Moulton Taylor, stood out from designs like the UFO-shaped Avrocar. It was built to smoothly transition from driving to flying and back to driving without interruptions. Even Ford once considered bringing this vehicle to market. One of the boldest attempts to make flying cars a reality came from Paul Moeller, who invested millions and nearly 4 decades developing the Skycar. In 2017, he put his creation up for sale on eBay with a set price of $5 million. Today, the future of flying cars looks much brighter. Gone are the days of attaching a plane to a minivan. Vehicles like the Aeromobile 4.0 and Klein Vision Aircar show much more promise for the sky roads of tomorrow. For flying cars to succeed, they need to be safe and reliable on both roads and in the air. Currently, they still require manual operation by both a driver and a pilot. For widespread use, they will also need to be environmentally friendly, capable of flying without requiring a licensed pilot, and priced reasonably for buyers to afford both the vehicle and its maintenance. There are many design variations, ranging from cars adapted to fly, like the AVE Mizar, to planes adjusted for road use, like the plane-driven PD-1. Most of these are purpose-built flying car models. On the road, wheels handle propulsion, while in the air, lift is provided by fixed wings, helicopter rotors, or direct engine thrust. A unique example is the Aleph Model A, where the car's body is hollow and its sides serve as wings. Once airborne, the car rotates sideways, transforming into a biplane, while the cabin remains upright. What do you think of this new flying car? Do you look forward to riding in one? Drop your thoughts in the comments. If you enjoyed this video, remember to like, share, and subscribe to our channel. Don't forget to check out the next video on your screen. You will enjoy it.